In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument...
All right. All right, Toby,
so
we are live.
I need grade school to do that and to answer at least, right?
It just means grab a little tiny chair and sit in a circle, bro. It's no big deal.
Okay.
Yo, hello everybody tuning in on Aether Cosmology and Space Audits, and I guess if you were listening on EADL, then you were already tuned in. But so tonight, kind of a last-minute change of plans. We seem to not have Cassandra with us, so we do not have part 2 of Hildegard. So we were all looking forward to that quite a bit, but it looks like it's going to be delayed yet again, so I apologize for the inconvenience. Hopefully we'll have it in the near future. As soon as we have more info, we'll pass that along. But need not fear. Tonight we are going to do an open discussion, a more, actual quote unquote round table, less of the presentation type of thing that this turned into, and more of a, whatever you want to say about the sun. We also have some content that Shane's going to be sharing here. But if you want to join the discussion tonight, feel free to join us on the Discord server here. You can find us at Discord. Currently, you can find us at discord.gg/ethercosmology. But you're better off and easier probably just to go to ethercosmology.com and then clicking on the little Discord link on the left side. And also that way, if or when we lose our Nitro boost or whatever on Discord, you can still find us there because whatever the arbitrary link address is will still be linked through ethercosmology.com. So check that out. And then without further ado, let's go ahead and open things up. Shane, if you wanted to just kind of start things off for us, or if anyone had any thoughts or questions, we can just open it up.
Sure. Yeah, dude. Thanks, everyone. We wanted all to see Cassandra's presentation. Maybe he'll be back. Maybe something happened. Maybe he forgot. No big deal. We can always roll with the flow. Let's talk about like the thing that everyone thinks is our biggest bane, that was like the first thing that we conquered when we all adopted a limit to our vision. And also, just like the basic question, who knows like the Glober's biggest win regarding the sun against us? Just just bros here, pretend like we're not streaming and that they're not listening, taking notes, because it doesn't matter.
Sunsets. It goes below the horizon.
Maybe. I mean, they all say that, but like, what's our actual biggest problem?
Angular size.
What'd you say?
He said angular size.
Angular size? No, I mean that's a pretty good guess. That's a common one that they always talk about. But like, there's the common ones that everyone always talks about, and then there's the things that like are intellectually viable, and there's only like one or two. But I'll just say the one I'm thinking of is triangulation. Right? Like, who's tried to triangulate the sun from more than 2 spots without it being extended to perpendicular perpetuity?
Well, Red's Rhetoric has given it quite a few tries, and that's actually, it's what kind of like ruined his YouTube channel. He was never actually able to do it in a meaningful way without making assumptions that, give globularity.
Right. So I'm just going to assume that everyone has a viewing limit that is the same that they told what the dimensions of the globe were. And then everything works exactly as it should. I'm also going to kind of go crazy and say that there's no basis for any sort of like geometric convergence. Like, I put a whole bunch of stuff on Twitter today about apparent versus actual, and Toby talks about this all the time. But I'm going to venture that there is no actual. There's only apparent. You only deal with apparent. We have charts based on apparent. You only ever get apparent using an alt as grid. You only ever deal with, use, and see apparent. So when they tell you, well, actually, it's converging at the bottom of a ball, that's all entirely dependent on the model. None of that ever happens in reality. So there is no convergence in the South. Like, there is no optic thing that happens like that. Anyway, as far as the sun goes, dude, the sun is like 100% of globe evidence. What do you guys think of that?
seems to be the biggest proof that they put forward, and the simplest one, because you can just say things like sunset and whatnot. But when you said that there's no optical convergence, what did you mean by that? Did you mean like the equatorial, like when you go to the equator and you see that divergence from the north, or what?
No, so see if I can. There was a video a while back, but there was like someone on the Gleason's map triangulating a position of a sun visible by 3 parties. In like
Oh,
3...
I'm sorry. You're talking about the angles that they for the triangulation.
Sort of. I mean, the angles
Gotcha.
aren't. They're not really. Yeah, they're not really doing the right thing by drawing angles. But like,
Yeah,
moreover,
I got you.
trying to find like a position of an actual body in space that will simultaneously appear in all the 3 apparent positions that it will appear to be in from those positions, right? And they're trying to draw to a thing to get those points to converge and say this is where the sun is. But in reality, they've never had that, right? That's never been a thing. They only get away with saying that because they take those angles and they push them to infinity, right? Parallel for forever. And it just keeps going. So they don't ever converge. So that's how they get away with it, right? Like, it converges if it's parallel, everyone's 90 degrees.
That brings up my question. My question would be, do these people even know what the sun is?
No, let's stick to this though. That's way too much.
Well, it's a legitimate question though, you know? If
Well,
you don't
come
know
on.
what the sun is, how can
Well,
you
listen, you stupid flare. If we know spectroscopy was stellar burning in gases, and another one we're taking readings of a hydrogen, helium, hydrogen gas, we know that's a burning ball of such gases burning hydrogen, helium, barium, all those iron, and then it would actually disperse into a supernova, which creates all the particles that create you, that actually form the dust, which forms the accretion, which means the gravitation from one particle, a bigger particle, it jumps a lump, which jumps a thing, which makes a ball, which makes a sphere, which makes a planet, which makes the galaxy, which makes a solar system, which makes the universe. Chump. So I mean, like, come on, Fleur, what do you know?
Cool story, bro.
But anyway, the angles to the sun, dude. Like this right here, this meme I put out, and I think it says a lot because on the left is what people like think is happening, and it's just misunderstood with what's happening on the right. Right? Because everything can be represented if they just pretend that it's a globe, right? Because even back from Eratosthenes, when he was like, I'm gonna definitely prove the size of the Earth, and his entire method was, okay, look at the sun. Okay, all done. I took the size of the Earth, and nobody was like, So you measure beneath their feet by looking directly up at the sky. Okay, all right, okay, I'm following. But how? And it's like, well, we just assumed that everything was this and light was parallel and that the sun was not like. If you actually assume that you have a vision limit, then all of that makes perfect sense, and you just mark out the sun's like solar circumference around an equinox near Alexandria. Did I lose everyone?
No, we're with you. Familiar with the story.
What about something like this? You guys like this demonstration? Perfect. Like it's like it doesn't. Nothing can make the sun go below you, and it's like, what about when a car with headlights at nighttime in the desert goes along a really straight line until you can't see its light anymore? What would you call that? People like it's not the same. I don't want to answer any questions. It's like, yeah, well, that's something that's really vibrant and bright, or whatever luminosity that goes a distance away and takes its light with it due to being unable to resolve it due to distance, right? There's a direct angular formula that you can do that'll determine that, and everyone knows. And they're like, yeah, but that doesn't apply to the sun for some mysterious reason. Like, why? Why though? Well, of course it does. They just assume that they can see forever, and that particles are infinite, and light is little particles bouncing off each
Dude,
other.
just by asserting a few baseline things, like that changes the whole dynamics of the interpretation, right? When you set the sun at infinity, you're like, and then you have your mechanism for assuming parallel rays, and then from that you can justify the shape of the ground being the reason of what you see in the sky, right? Is that?
Yeah, it's like a series of backwards arcs that you have to do when you like bend over backwards to make it make sense. It's like, you see how the sun has an arc? Yeah, that's how we know the Earth is curved. And you're like, well, like counterpoint, maybe that just determines like exactly how far the sun can go. Like if you look at it like this right here, you have that little animation playing, which is just like an annual rotation of the sun. And if you map it out, one of these rotations lines up perfectly with this diameter, radius, and circumference, right? Ruhiv took one look at this and he was like, is that circumference the same as the globe Earth and the same radius? I was like, yep. He's like, okay, moving on. He was like, done.
Oh shoot.
I think it means that it makes perfect sense. And that he was unwilling to talk about it, but I could be wrong. What about old school like crepuscular
Makes
rays?
sense. Hold on.
Yeah, see, that's just a cool video for background. But he went like, dude, crepuscular rays are the biggest proof. They have to like be like, okay, even though this is the only thing that anyone's ever seen in the history of humanity, we're gonna go ahead and assume mathematically, for the sake of practicality, that actually all light is parallel, and assuming that it takes for the speed of light to get to us from the sun, which is 93 million miles away. And it's like, cool. And you're just gonna assume all that, are you? And they're like, yep. Does anyone know the scientific basis of first assuming that light was parallel?
No, never heard of her.
Eratosthenes, homies.
Oh,
Eratosthenes.
yeah. Aside from that, I thought there was like a different one.
Oh, like a real one that they didn't
yeah.
make up? No. Even in their made up fake Greek story, they're like, yeah. So, look, we assume straight up that all light was parallel. Yeah, there's no basis, and it's never been seen by any human ever, and there's literally can't prove it. And we're just gonna keep assuming it. And then, the second measurement, when little Eratosthenes took his reading of the sun, and he got the equinox, and he went from Alexandria to Cyrene, 800 kilometers away, and there was a 7.2 degree difference. He was like, all right, you know what would solve this? If light wasn't parallel and it was crepuscular, then this observation makes perfect sense for the flat Earth. Then it was like, no, that's not it. You know what it is? The whole world, the whole galaxy that we just invented and made up is tilted at 23.4 degrees, and that's why it's not parallel. And to understand that, I think I have a better GIF. Like the celestial sphere.
Dude.
Let's go back.
But to be fair, the galaxy is tilted at 23 degrees or whatever. So
like this guy, right? Like if we just took this guy and we made him perpendicular, if it was all just coming down, that's what he's assuming it should be like. And he's like, it's not like that. We get this. So you know what it is? It's not local. It's not local light. It's that the whole galaxy is tilted at this degree. That's why we're getting this, of course, perfectly perpendicular light at this weird angle. Anyway, fun knowledge if anyone wanted to know the entire scientific basis for assuming that light was parallel in the first place that nobody's ever seen by any human being ever. Anyway, back to the sun, our lovely sun that can't be triangulated with any more than two positions, right? Dude, didn't Whitsitt ask Dave in the debate like what anti-crepuscular rays, and he was like, I don't have to know what that means to know that you're stupid, or whatever he said.
Yeah, tell me what they are with.
Yeah, he was like, you tell me what they are, smart buddy, or whatever. And literally, this is what they are, guys. It's like the perspective-induced counter-convergent rays that your perspective puts these parallel sun rays into as it morphs them into a sphere around you. Call that sphere what you will, right? You guys call it the globe, actually. We just call it the limit of our vision, and this is the first perfect daytime example of showing you exactly that.
The recent weather has been weirdly warm, but what happened Sunday evening seemed to defy logic. One glance at this picture and it would appear the sun was positioned below the northeast horizon. Light seems to be emanating from behind the mountains, but it was late afternoon, and the last time I checked, the sun sets in the west. Indeed, the sun was setting low in the southwestern sky, but shadows and light from a mix of clouds and the sun made it appear like the sun was setting to the northeast. Crepuscular rays are beams of light that appear to converge on the sun.
He's never said that word before, I don't
beams
think.
Of light before. But what happened Sunday evening was anti-crepuscular or anti-solar rays that converge in the opposite direction, and you must have your back to the sun or sunset point to see them. The low clouds in the foreground are lit up by the sun. Shadows behind these clouds extend out towards the horizon opposite of the sun. Anti-crepuscular rays are a meteorological
Poor
optical
guy.
phenomenon. They are essentially
Is he just reading from
parallel, but
Google?
appear to
Yeah,
be
he's
different
definitely
towards
just
the
reading from
vanishing
Google
Is
for
that
the
what?
news,
Is that
dude.
not what you just pulled up in the last slide? That's one-to-one Google, bro.
Yeah, dude. Well, I
He
did
needed
that.
to use more syrup on his crepuscular ray.
Yeah, dude, he's never said it out loud. He's never heard another human being say it out loud. I'm pretty sure he's reading it for the
No.
first time from Google, and this is a newscaster on the regular, whatever.
Got them
Yo,
crepusculars.
how can anti-crepuscular rays even happen on the globe? Now that I'm thinking about it, they happen when the sun's like already set, right? So how does that even make sense on the globe?
Well, they're assuming that it's parallel and that everything they see is counter to that. So it actually just forms this magical bubble of perspective that only you can see, that nobody else can see. But in reality, dude, honestly, when I say it out loud, I can't even coherently get it out as an argument. What is the argument? Somebody do it.
That is bizarre. Like I always assume that they like crepuscular rays, they could get away with saying that they're parallel just because of perspective, right? Because the sun's so far away, even if they were coming in parallel, they would look like they have like that, crepuscular shape to them. And I could imagine that going over my head, and I could even imagine them going and converging again as anti-crepuscular rays. But I can't imagine that if the sun's already down behind the ball.
Yeah, that makes literally no sense.
Yeah, so you're saying that if we see in a uniformly illuminated distribution of light, our perspective will turn it into a sphere for us?
Yes. Yeah.
Okay, so the idea that the illumination has to come from a parallel light ray from 96 trillion, or whoops, that's the wrong fake number, 93 million miles away isn't it's not the when you have the curved visual space, like you don't have to have that as the causal mechanism to explain why you're looking at what appears to be a bent parallel lines, right?
Yeah, and in this one case, like we don't even have to disagree, because in both models and in reality, perspective is the mechanism that is to blame for this, bending light ray. So even if it is in reality, objectively, which nobody can ever confirm because we can only view it as crepuscular, even if it is parallel, the explanation is the same, right? Your perspective is doing this. Your perspective is doing this. Your perspective is doing this. That's the only point I keep trying to use this for, right? And I don't like they still fight it. Like, oh, that's stupid. What does it have to do with starlight or whatever? Is probably the next thing.
Like everything. Like, no, it's only related to this, not the stars.
Yep. Like when I went to bring it to Glover, that's usually the next thing. Once they're like, okay, I see how this whole thing being an aspect of perspective is related to you saying that perspective is the cause for things. Okay, that makes sense. It's like once they accept that, they're like, yeah, but starlight isn't sunlight, you stupid flirt. It's like, okay, all right. We can cover that, right? We can always cover that. Dude, I found some good anti-crepuscular pictures, though. What do you guys think of these? This is cool.
They're very nice.
Literally happens all the time. I mean, I've never seen
It's
it,
an
sure.
anti-rotation in the same
Ooh,
way
P-brain.
that anti-crepuscular rays.
Yeah, we don't have time for that, though. But this, there we go. Nice visualization. Showing exactly one ray is showing the convergence and then the counter convergence. Which they would, if they were to rotate, he was arguing they would go one direction and then the other way, similar to the paper towel, rotating one direction when you look left and the counter rotation when you look right. That's the whole analogous concept here, right? And they're like, oh, it has nothing to do with it, and it's like, well, no, it's exactly the same. It's the same effect that happens during the daytime with sunlight that your brain would then do at nighttime. It's just kind of the counter convergence, but. And then they're like, no, it doesn't. You could never make. What height does the sun have to be for this to be 0 for my angular resolution limit telling me what to tell you that it's 0, you stupid flirt? But it's like the math that you're using, right? Basic trig isn't to blame. It's your retarded application of that math that is to blame. And that's always going to be the case. It's never the calculation technically that unless you're really stupid, right? Publicly, you're never going to be doing a wrong calculation. You're just going to be applying said calculation in a retarded manner. You're going to be saying, based on me being able to see forever infinitely and light being little particle balls that extend in a non-energetic background in perpetuity, endlessly perpetuating each other to ad infinitum. It's like, okay. But assuming all that, then this doesn't make any sense, right? But if you're like, okay, light attenuates over distance, atmospheric opacity exists, things disappear into and around the horizon all the time. It's a limit of your vision of your view. It literally, like, if you comport the limits of the radius and the radius criteria to your limit, then it just comports to a circumference of let's say 24,901 miles, maybe, or something, or around there, or exactly there, actually, right?
The element of everything you mentioned there was opacity. And we see that in the videos, that we see the fade long before we see it completely hit the horizon.
Yep. It goes right into
It
the
just
vanishing
depends on
line.
where you are.
Yeah, I would say it goes into the horizon, right? Never over it. It always goes into it every single time, just like this. And of course, it's just because of the limits being so close to the bottom versus the top, in the same way you see when it goes down a hallway, when you make those transverse lines and the orthogonal lines, the basic facet of perspective of things disappearing into the horizon being the apparent position where the sky meets the land. Literally a facet of perspective, optical in nature, by definition, a facet of perspective. Man. So it's like, how can that sun do the same thing that everything does when it gets far enough away from you? It's like, well, I mean, exactly the way that everything else does. What do you mean? It absorbs bottom up angular resolution limit, just because it's closer to the bottom limit than the top. It absolutely has to be that way for bottom up obstruction, right? We use this to tell you get this paired angle idea. You do some math, you do some quantification, you get like both of these angles have to be met for something to disappear. And even though you're from the bottom so much closer, what happens is it obstructs from the bottom much quicker than from the top, right? That's all it is, guys. It's super easy. Just that you're down here looking at something, right? And say your skybox, which is technically the sky, is way the fuck up here, right? Way up here. And you have the ocean, the horizon, waves, ground, atmospheric, deck opacity, like leaves, everything that is the horizon right here. Our buddy Ruhiv won't even talk to you about refraction right here. He'll invoke refraction of a sphere of infinite radius at this level. So you want to get up to this level before you want to start talking to Ruhiv. This is about 100 meters above. This is where you want to start, because it just bends down. I'm just kidding. It's super boring. But here's when it actually, like, of course it starts bottom up. It has to. Look at how much more up top. Look at the difference in these angles versus the corresponding angles down here that have to disappear at the proportionate rate, right? Imagine an angle around a circle contracting and just having to correspondingly represent the missing 360 degrees as this acute angle grows bigger and this one grows, like, right? Everyone following?
Yeah.
So then when things go past this resolution limit and they become unresolvable to you, right? They go past your ability to resolve them, they become invisible. And something like the sun brings its light with it. You get twilight, dusk, sunlight, things like that, because the plasma field around it will go with it, but at a slower rate. So that's why you get, like, dusk, dawn, orange, indigo, twilight, things like that.
Yet a little off topic, but just to toss in there, as you go up through the different, they call them the different layers of the atmosphere, different layers of the atmos, you have, according to them, fluctuating temperatures that go from cold to hot to cold to hot. So that's also going to really affect the medium that we're looking at every time we're looking at the sky. So that's also going to really play into the whole apparent positions thing. Because you think about the angle changing through those different cold to hot mediums.
Yeah, that probably creates these mirages, honestly, dude. When you get, like, super hot or super cold stuff, you get this optical phenomenon that just makes everything look goofy. And then they're like, look, see how that boat is behind the Earth curve? And you're like, haven't you ever seen a highway on a hot day, bro? What do you mean behind the Earth curve? Like, no, there's a video of a quarter of someone doing it. Anyway.
Yeah, if you're out driving, ever since we started having these discussions, you just out driving on a hot day, a hot dry day or whatever, and you see your diffraction limit getting hit all over the place on the road.
Yep.
It's a really, really normal thing to happen.
Right, because even people looking at these pictures will be like, yeah, I've seen that before, and honestly, like, in my life.
Hey, are you talking about when Earth radius jumps up a little bit and changes?
Yeah.
Yep.
Yeah, exactly that. Yeah, when it just spikes, like when you get, like, opacity deck that's really opaque and you can't see and it's dense, it'll be like,
you find it for a little bit.
You find the temporary
right up,
find the curve.
becomes easier to find the bigger it gets, as Ruhiv says, and he'll go to near infinite. But the more opacity it is, the bigger that radius has to get. So he just pumps it up until you can pop it right back over that non-existent curve. But yeah, in addition to angular resolution limit and radius criterion, of course, being the thing at which become the rate at which things become resolvable, but two become resolvable into one, and when one becomes unresolvable from anything, right? As Bruhip so nicely pointed out in our debate, you have this horizon distance being set by the bottom always, because you need both of those to diverge completely for it to become invisible or unresolvable. And the only way that can happen is if proportionately this disappears bottom up from this portion first, so it can meet the corresponding rate from this corresponding angle coming from the other side. And that's represented orthographically over here, right? We interpret this same thing. We see these angles. Oh wait, am I not talking?
You
Crap.
are talking.
No, we hear you.
You're good.
I just remembered that I had voice push to talk, and I couldn't remember if I was pushing it. Let me turn that off.
You are pushing
All right, cool.
and
Nice. So
talking.
then, nice. Well, let's pause for more open questions. What do you guys think of sunsets are impossible on a flat Earth, but you don't like the personal vision radius? Let's hear from those people.
Can a mirage obstruct things?
Can a mirage obstruct things?
Uh-huh.
No,
I mean,
it distorts them. It doesn't obstruct them.
This is amazing work. Thank you.
Well, what's the difference?
Well, you see, the globies like to say it's refraction as if it's a phenomenon that helps us better see something in more detail or as something to that effect. Somehow we're overcoming something that's natural because of the mechanism of refraction when the opposite is true. That refraction is a function of distortion across a planar limit.
You're quoting me from like years ago. I love it.
So it's not helping you see something better. It's fucking it up in a very specific geometric way. And you see less of it, in fact. You know?
But a
So
mirage that can be like very squiggly and disorienting.
yes,
That can
but never the
obstruct
full
anything
object,
that's
right?
behind it.
What's
The point is that it always distorts the physical height of the object because it's perpendicular in that way to the plane of distortion here.
Well, if a
Of
mirage is
the
in front of the object, then you wouldn't see the object behind it, right? Like a building.
Are you saying that mirages can obstruct rigs?
I'm saying absolutely a mirage can obstruct things. It's just another type of refraction, right? It's either the angle or it's some kind of heat fluctuation. It's an internal reflection sometimes. It absolutely can obstruct things. This is a point that people never talk
in
about.
superior
So I just want to make
mirages,
a point of it.
the ones that he shows here, it's always you're seeing the mirage in the medium below the object, ahead of the object, in front of the object, closer to you than the object. It's not obstructing the object. It's not revealing the object. It is separate from the object optically.
In those examples, yeah.
No, in all mirages, the mirage part is separate optically, vertically from the object. That's the point of the mirage.
Yeah, I agree.
And as it does that, the view of the actual object is also distorted in every case because of the mirage conducive conditions in the atmospheric stack, right?
Yeah, I'd agree.
So none of it helps you see the object better or more clearly or from farther away. It's that it distorts it more the farther away that it is, the more heat imbalance between you and the object exists,
It's like
etc.
a clown mirror. Doesn't help you see more things,
Yes,
things
like the
more
Holocaust
clearly.
mirror.
Mhm.
It's a mirror that clowns use, globe clowns.
I could get behind that. So anyway, mirages, I guess, dude. Like I don't think I could fight against that. It can make this appear thing to be appear like they can pretend that what they don't see and what is reflected and or obstructed and or absorbed into this horizon line, or not reflected, because sometimes you'll see the bottom, sometimes you won't. They can just claim that's Earth curve all the time. And the fact that they're still doing that when we brought up things like angular resolution limits and real optical factors, like, you have a limit in light attenuation and atmospheric opacity and all these things, and they're still like, yeah, we know all that's real and substantiated and mathematically based, but we're going to go ahead and not account for any of that ever, and we're going to account all of that for Earth curve, kind of like how all the flu deaths became COVID. Is everyone cool with that? Yeah.
Oh, so we're just going to look at the angle measured and assume cause is Earth curve and account for none of the optical effects that exist? Except for specific ones?
That our instrument precision is absolute to the fraction of a second of a degree. We're there, man. At 100 miles away to the target, our instrument is absolutely precise.
Yep. And we're
Not
just
that it matters in the least.
Dude, there's no way to measure absolute motion, but there is absolute optics.
Absolute curvature, physical curvature that you can only measure optically. Don't you know, douchebag, that optic curvature is physical? There is physicality within the optical curvature that is to manifest physically. Dude, I'm trying to be like the best glober in word salad, dude, but I think even that is too good.
The shorter the optical path of all your lenses, the more precise it is.
Yeah, so I mean, the sun is just the best example of the angular resolution limit, I think. Happens all the time, every day. People constantly misunderstand it. It's like the classic example. It's like the globe proof, the best globe proof that always ends up being our proof, right? It's like sunsets prove the globe, and it's like, well, only if you're an idiot, right? And you don't understand optical limits, angular resolution limits, radius criterion, exactly what an optical limit derived from a radius 3959 and an optical drop rate of 8 inches per mile squared at a parabolic rate. If you're not familiar with what any of that means, then sure.
And the likely magnification of the medium that's occurring.
Right at the horizon, like right here, which is probably exactly why you get things like the green flash, right? And the sun just like absorbing into nothing. And also would be why you get things like the fade outs. Actually, let's switch this up real quick. Let's quickly go to database view. Change windows to this. Yeah, cool. I tried to pump this up. I literally have a tab on like the sun and the moon that is just all these optic stuff too.
Nice Dracula theme.
You like that? Did you? Come on, sun and moon. Nice. Oh, wait, hold on. Stream's got it. Okay, we're good. So, what is this? Exactly the same thing. Yeah, atmospheric compression. These depths. It just takes 8-hour shots of the same area to show you in the same. Like that's, I think it's going to be the same thing that we always show. The ridiculous threshold of limit of how it fluctuates, and it's like that rotating Earth curve sure is freaking wobbly at all these depths and distances. It's like, man, sure is wobbly. But anyway, let's go to what I was looking for, which is over here. Sunsets and disappearances, right? An angular resolution sunset of it disappearing bottom up perfectly, right? Is this not exactly it? We should watch this, I think.
The laser is above the top trellis net.
One of my favorite representations for sure. And when people say my warehouse is curved, right? This is the one you want to whip out.
It's focused on the vanishing point. So everything's legit here. We're going to see how sunset and rise works.
Wow, can you send me this video when you're done?
You don't have it, dude? I thought I got
No.
it from you.
No, I need it in the arsenal.
Okay.
That's insane.
Yeah, I mean, guys, there's no secret ready, but watch. You guys can see my mouse, right? You
Yeah.
can see this button
Right.
that you can click and then download.
Oh, right. It's on your ADL.place. Gotcha. I gotcha.
It's on the Sun and Moon tab. If you use the search feature or the navigation bar on the left or any.
Yeah, I gotcha.
It's not you. It's everybody. Nobody uses it. I'm pretty sure. Anyway.
Yeah, that's a great video.
Honestly, if we have like open license to show things, we can be deadly. Like this whole argument is deadly with lots of proper visuals and screen sharing. This is where the headlights in the distant desert comes from, right? It's like, that would never happen. And it's like, oh, you're going to see those headlights in perpetuity? And it's like, no, that's retarded. Oh. Like, oh.
Oh, look, the Earth's rotating back into his frame. And the curvature's working out.
Sunset. And it's like, not only that, it looks exactly. And then, of course, you got this one. Right? The warehouse one.
No, this is the one I had.
Yep. It's a good one, too, though.
It's pretty decent. But his warehouse is curved at 8 inches per mile squared, so...
That is the argument I heard. So somebody made that argument.
Dude's got a fisheye warehouse.
That's a better argument than the warehouse is curved.
Hey, you know what? But to be fair, like I was telling you, I was arguing with someone and was like, what do you think your granite counter is curved? And then it turned out to be slightly curved when he measured it, so. Gotta watch out for that.
But this guy takes this sun model and it like literally resets into the horizon, into the resolution limit that we just discussed and went over and looked at. And it's like, oh, look at that. It's doing exactly the thing. Every time. It's like, oh, is it exactly fitting the model and being logically cohesive again? Damn flat earthers. And then, of course, there's this wonderful example of the angular resolution limit not being an issue, being you have a thick enough lens that you're viewing an object where it will encroach in size and not change size to you based on distance. I think I said that in too many words. Stone, can you clean that up for me?
It's really about
I was actually just catching up. Hey,
I'm going to stammer through it again. I think it's this video shows how proper lensing will show you how an object can maintain its angular size regardless of its distance, I think.
Well, that was much better.
well, that's what Fresnel is doing for you. Yes. Well,
Yeah, I did do a much better job that time. You're right.
Yeah, I'm a big fan of this one.
Have you guys seen the do-it-yourself video where he makes the artificial sunlight? He does a nice rendition of Infinite Sun at different distances and maintaining its angular size. Oh, 1 second, I'll send you the link. It's a good video.
We'll add it to the database right now, live time.
Yeah, absolutely. DIY Sun.
Dude, this is one literally bringing it back up off of its convergence into the atmospheric depth of opacity, right? It's like converged, and the dude brings it back, and it's like, nah. And they're always like, show me a video of it doing exactly this, and you're like, haha, this, and they're like, no. I think it's like solar filter after that. That's what they start chanting. Like, no.
just an illusion, bro. It actually set 5 minutes ago. It's already down. You just
It's already gone. It's already gone. Yo, I sent you the link with the timestamps when you get a second. Pull it up.
All right.
Yeah, he uses some parabolic mirrors to do some parallel rays and make the illusion of an infinite or a disk that has an infinite or a fixed size, and you could move it any distance and it stays the same size. It's very cool.
Yeah, that's the one I was thinking of actually when I was trying to show it. Let's do this. Change screen again real quick. We'll come back to the database though, because we're not done with that. I'm good for this. Somehow OBS is on point. I don't know. It's cool.
Another fascinating result is that anything at the lens's focal point appears to be pinned at infinity and appears the same size no matter whether you're close to it or far away, as we observed in my recent DIY projector project. So, success, right? Well, to a degree, yes, but the diameter of your lens directly dictates the size of your area of projected sunlight. So you need a massive lens to really get the best out of it if you're using a single point light source. And even if you use lenses of the Fresnel variety, this can get pretty expensive.
Yeah.
And you still have some issues to contend with, such as lens directly dictates another it makes them parallel. These newly collimated rays now have some of the characteristics of the sun.
Rewind it a little bit further if you want to see how he makes the lens.
As we can just use a parallel rays with a local light source isn't particularly difficult, as we can just use a lens. You see, when the lens is placed in front of the light at the lens's
parallel light rays require a lens.
Collimates the light rays, which means that it makes them.
It's amazing how everyone knows that from that fake Greek that one time that everyone. Wait! Wait!
He's sick. Whoa.
Parallel. These newly collimated rays now have some of the characteristics of the sun, namely that the light intensity doesn't change because of distance alone, and shadows don't change in size either, which is super interesting to see. Another fascinating result is that anything at the lens's focal point appears to be pinned at infinity, and appears the same size no matter whether you're close to it or far away, as we observed in my recent DIY projector project.
His optics are so grimy.
Stone could do it better.
So, success, right?
That optical
well, to a degree,
grime.
yes, but the diameter of your lens directly dictates, however, or so you might assume.
All right. That's enough of that guy, I think.
Walk the heck. Oh.
I'm from jolly old England, mate.
I can't believe that's a 19-minute video, dude. Like, what could you possibly have
Dude,
to offer me beyond that?
It's a cool video. I've watched it several times. How dare you?
Oh, yeah, all of it. You watched all 18 minutes of that
on
normal speed with attention and everything.
What was that?
Like,
what was
I
that?
watched it once in the background while playing RuneScape. I get it. That's fair. It's not really
2.0.
Yeah, you got me. You got me. Fair enough, boys. Fair enough.
I hear you scratching your beard again. Knock it off.
Dang.
Dude, this is one of my favorites. What is this? No, that's the one we already did. I don't think I have that's another one. Whoa, gay music. I think I have David Weiss's like sun fade out thing on here times 6. I think
Yeah,
I
the
watch that
pièce de
one too.
résistance.
Yep, definitely my favorite. Since we're just doing a night of watching cool sun stuff, so all the people who are like, sunsets debunk you, and it's like, yeah, I'm up here and I've never seen nighttime and thought, I wonder what that,
What
model seems broken.
What are you?
Like, this is the same video. All right, I see that I have to close that or it will stop playing. All my stuff is broken. No one look at that. Cool. What is this one? Okay, a time lapse of it literally just like fading away. It's like, the sun doesn't do that, Flurf. It's a perfect disk that recedes into the horizon because it's below your feet. When you don't see it, where do you think the rest of it is, dummy? It's like resolved into the depth of opacity commonly referred to by the unresolvable limit past the Ray's criterion, which would be the limit, I would say, between 3959 and 6210 miles. That's what I think. What do you think? Goes beneath my feet. Well, that's retarded. I mean, it's like, wouldn't it look exactly like that if it was going further and further away and receding until it became unresolvable as it approached the horizon, literally a little bit above where that car is now? Maybe it's just me.
No, it seems uniquely independent to the shape of the Earth being the causal mechanism. Honestly, the more I look at it,
But if it was flat, stupid flurf, it would do it would do exactly that. Wait a
well,
second.
this is the crux of it, right? This is why this can't be admitted, because once that goes, it's over, right? It's like,
Wait, it would do exactly. Wait, hold on. What would it do?
what would you? Okay, let's say you're a Glober, Shane, and you get presented with your boy optical derivation of the radius, and the limit of vision just happens to meet where the sun dies in the sky for you, right? So what would your next argument be to substantiate globularity in the antipodal theory?
I would then go to the exact same observation, but like flip it 90 degrees and pretend it's nighttime and be like, well, yeah, but like in the south, there are other stars that go around the thing.
They're upside
Definitely the
down
bottom of
and
the
in the
ball.
dark.
Yeah. Yep.
Nice.
Yep. That would be my best Glober defense. I would be a great Glober though. I would quickly lily pad, so like I would just list topics like rapid fire that I could answer faster or whatever, because that's the argument, I guess. If I can answer faster, then I win, I think.
Yeah.
But this one's good because it's like, no, it would get smaller, and it's like, oh, it does. But you don't have a filter on it. It's like, oh, so your argument is the glare that makes it get smaller. It should be eliminated from the observation that makes it get smaller, so that you can claim that it doesn't get smaller, even though it observably gets smaller with a filter too, just at a noticeably smaller degree. Literally, it obeys everything that it would if it was, rising and setting, because it's coming closer and then going further away.
I've got some more evidence. Another cool video to stream. I'm just upping it right now. It's 28 meg. It'll be there in no time.
Nice.
It's of the sun coming through my door, my front door window, and it's on the west side of the house. So I catch the sundown, and this is actually October, so it's 6. You know what I mean? It's kind of like late April for you guys in the northern hemisphere as far as where the sun is in the sky. You can pull that down now, Shane, if you want. It's in the live chat. And when it gets closer to the horizon, the light on the door goes clear across the room and hits the far wall, and then crawls up the wall as the sun goes down. But as the sun, quote, sets, you see the rate at which it crawls up the wall approach 0 as it fades out. It doesn't move across an ecliptic on the wall. You know what I mean? This is my response to a video somebody put out, I don't know, a year or 2 ago. You guys remember that one where the guy got a bunch of simulation software and he mimicked both and what
Oh,
you would
dude.
expect it like
Yeah.
on the wall going through the window?
Yeah.
This is a
that.
replication of that simulation
I was just
to
thinking,
show you which one it really is.
dude, nice. Dude, yeah, can we
So go ahead.
Yeah, while you're doing that, I'm gonna look up the simulated video real quick for
Dude,
context.
Bennett
That's
has,
awesome
some
that
videos.
dude, that's awesome that you substantiated it. That's great.
Yeah, it's
Hell
a
yeah.
real-time measurement. Check it out, man. Play it out.
We're gonna watch it all together, and anyone who has other cool sun videos that you think we should watch, throw them out. Right? This is a fun time I'm having. This is chilling with the boys. Let's do it.
There's nothing like a hardcore observation like this here. I show it once, I think pretty much real time, and then again towards the end of the clip, I show it sped up. So you can obviously see the rate slow down and fade out. And the whole clip is 2 minutes. You know,
Is there no
this thing is
sound? Oh.
all day. No, there's no sound at all. This thing
Oh.
spent all day crawling up the wall to get there. I mean, but now that it's near the horizon, crawl has creeped to nearly 0 at this point. And then it just fades out, man. The sun just goes away.
All right, let's see.
That's my Krasniansky on the right.
On a ball, though, right? It should be equidistant everywhere. It should be like instant sunlight, perpendicular to everyone. It's soon to be parallel. And then, it shouldn't be this like.
It should be constantly climbing on the wall. It should never come to zero like this. It should always moving up the wall until it disappears, right? Well, this thing slows down to zero.
Yeah,
This is
right.
just the last minutes, right?
Right before it disappears into the atmospheric deck.
And it's gone. There it goes. Bye. So
So
yeah, here it is. Here it is sped up, I think 4 times or something, 8 times. Whatever. Like here, you can see it's still going up. But in a while, it'll just stop before it fades out.
And
Pretty cool, hey.
pretty cool, Stone. Look at this.
And this is
Let
like
me ask you,
mid
Stone,
late October.
is it actually going up or is it diffracting?
Well, it's not diffracting, it's shooting straight across the room.
Well, no, I understand that. What I'm saying is that while it's growing at the top, is it also growing at the bottom?
No, it's not growing at all. It's just going up the wall. And its intensity is fading as its rate of climb up the wall approaches zero.
Stone just showing that he also has filmed exactly what we were looking at before. The phenomenon of the sun just like disappearing. It's like, oh, it's definitely going below us on a sphere. And it's like, yeah, what gave you that impression? The way it sits right before it disappears and then freezes at a non-constant rate of rotation, which wouldn't have been associated by a rotating sphere right on the horizon before it sinks into that deck of opacity. Is that why you think it's a giant sphere? It's crazy.
Something like that, yeah.
Literally, someone on Twitter today looked at took a sunset of it half setting and then completed the circle beneath it with like a crayon and then wrote in as a diss to me, where do you think the second half is? Literally. I was like, whoa. Real winner. Man, crazy. Oh, it's on pause? No, we don't want that. Dude, there's so many observations of sunlight doing exactly like the thing that is. But whenever they're like, if that were true, then this. It's always like, yeah, we have like infinite videos and photos of this, whatever this is at this time. And they're like, that doesn't count.
So, sorry, I had to step away for a second. Yes, it does go up the wall, but then at the point when it stops climbing, it seems to perhaps dilate, like the whole image that is coming through the window. So when you think it's starting to climb just a little bit more at the end, I think the whole image of the all of the light is actually kind of growing on the wall.
It is overcome by opacity such that we no longer see the sunlight, but we do see the daylight, which is a whole different mechanism of light production, right?
Right, but that's not what I was talking about.
You guys want to watch the next one, or is there?
Yeah, I couldn't.
Questions.
I couldn't find that
Did you find the source
simulation.
file, Alan? I think I've got it. Let me take a look.
Oh, perfect. Yeah, I thought it was on Taboo's channel, but couldn't find it. Yeah, it's a great video though. Yeah, it's basically somebody came on, and I think it was an architect or an engineer or something like that, used some simulation software to model out what Stone just measured. So Stone's video is like the reality version of what dude modeled, showing like the different predictions between both models of what would happen if the sun were setting, if it was due to Earth curvature and rotation versus an apparent object in the sky moving away from you, you know, and always being above you, right, and never going below you.
Nice. Look at new perspective stuff. And of course, stealing it all. as I am a dirty internet thief, as everybody knows.
Okay. File is coming up, and it's 56 meg. It's Taboo Conspiracy's version of it, so you can just like fast forward past the first, I don't know, 2 or 3 minutes of ramble, and then actually get to the substance of what the video's about. But yeah, almost done.
I think the do you have the sun angle video from the FE Core guy, Shane, too? That's a good one to talk about, show.
And it's up.
Yeah, magnetic flat earth. I walk around everywhere with like that in my wallet.
You got it in your wallet
so,
with an
yeah.
NTF? Yeah. There's a QR code.
Like, of course I have that.
Nice.
Oh, is this the... Oh. I thought it was the star video. It was like a pilot went to something. I was like, no.
Mhm.
All right. Change screen to this one. Go. All right, I'm on point tonight. Everything looks like it's working fine. We got audio. Everything's cool. We're flowing.
To share with you today
Let's
with respect to
see.
my team. Why is that so hard to understand? As I said before, but are his viewers this
Nah, we don't care.
Going to change that globe damning fact?
Next,
we have
I
propaganda.
don't know if this is the video.
Let's keep going. Is this the one I sent you?
Yeah.
One I just uploaded?
Yeah. Oh, no, there it is.
That's it right there.
There it is. And it has his YouTube channel in it. Shadow Reveal.
In part.
All right, let's see.
As a bit of a background, I'll explain how I stumbled on this.
Now go back like 10 seconds to get the guy's YouTube channel.
Which videos on the topic, which I'm looking for.
There it is. Shadow Reveal. That's the guy.
And debate will continue primarily on his channel. He also said that he'll be putting out more videos on the topic, which I'm looking forward to. I'll have a link in the description. This is what he wrote to me in part. As a bit of a background, I'll explain how I stumbled on this. I noticed something just prior to Christmas past which stuck in my head. I live in a small seaside town. A lot of trees were removed from neighboring properties towards the end of last year, which allowed the early morning winter sun rising over the sea to shine through the bushes to the east onto my kitchen window. Since moving here, I hadn't seen this before, so it drew my attention. A strong shadow of my kitchen window was cast on the opposite wall. Nothing surprising in that, but as I looked towards the sun, it seemed to be down the hill and lower than the house. However, I noticed that the height of the head of the window shadow on the wall was lower than the actual window head. Although I noticed it, the significance didn't strike me until I watched your Mount Rainier videos. At that point, I realized that the sun had to be higher than the house, even though I thought I was looking down the hill at it. In a nutshell, I believe that whichever of the following statements is proved true will definitively show whether we live on a globe or on a flat Earth. If the Earth were a globe, then the shadow of any object formed on a vertical surface must rise to a height greater than that object as the sun sets over a lower, unobstructed physical horizon. If the Earth was flat, then the shadow of any object formed on a vertical surface can never rise to a height greater than the height of that object as the sun sets over a lower, unobstructed optical horizon.
That's exactly what we see.
I was inspired to make a 3D Blender model to observe different sun position shadows. As an architect, I know that a picture paints 1,000 words and an animated 3D model paints 10,000. From the observations revealed by the model, I propose that simple observations are all that is needed to show our realm is flat. Also, simple observational experiments could be devised to show this to be the case almost anywhere. Arguably, the best would be made in a tall building with a shadow overlooking the sea, it could be the case that the shadow of that window on a wall in the room would regularly cast higher than the window itself if we live on a globe. If the Earth is flat, then the shadow of the window on the wall will rise slow, almost to a stop, and then fade out as the sun fades. It will never be higher than the height of the actual window head. A desert setting might also be good, as atmospheric distortion could be less. The fact is that this could be tested in the simplest ways. On the beach, overlooking the ocean,
Doesn't
a
show it
close shadow on
fading
a wall.
out completely
Indeed,
like I
does
do.
a person's shadow on a wall get taller as the sun goes down? I may make another video to illustrate the numerous observations that could be made and explore some of the model observations that aren't included in the first one. For example, the deceleration of the flat shadow as opposed to the constant speed of the globe version. This in itself would be a flat Earth proof, but perhaps a little harder to follow. I am also beginning to think that the shadow speeds may reveal some truths as to the distance of the sun. I fear that calculation, however, may require a more mathematical mind than mine. That's all I'm going to share of his email, but I do want to say that others have noticed this phenomenon as well. I remember Jeranism on the Globebusters a few years ago also mentioning the fact that he's never seen a shadow from a sunset appearing on his ceiling through a simple window. This architect's argument builds on that fact. I will be showing the architect's whole video at the end of this video in a few minutes, but look at this awesome Blender model. This is the globe model here. Notice what this is right here. That's the upward Earth bolt
Constant
shadow
rate.
that would overtake all other shadows that I mentioned in my Flat Earth Fact number 16 videos. It's much easier to see it than to explain it. Without question, if the Earth were a globe, this Earth bolt shadow would appear all the time, quickly preceding all other upward shadows at sunrise and overtaking all other upward shadows at sunset. Just like
That's
you see
such
in
a
this
good
model.
point.
Shadow Reveal calls it
Constant
the
climb
alleged
rate.
globe shadow of the physical horizon. And that's a good description. I consider that the ultimate shadow test of the shape of the Earth. If the upward globe physical horizon shadow exists, it unequivocally proves a globe-type model. If the upward shadow does not exist, then the Earth is flat. I consider this test even better than a force the line type test. It's so simple, and there's no debate here. Just red herrings, straw man arguments, and a bunch of morons slapping their heads, pretending as though they don't understand. In addition,
There's a bunch of people vaguely referencing some Greek that nobody's name can pronounce who definitely proves veracity more years ago than we have reliable history. I know that for sure. Yeah.
You got to admit, it's a pretty solid piece of observation, isn't it?
This is epic.
Man of Stonotosthenes proved it. He measured it in his kitchen. Dude, that's a great one, Stone.
Right here, bro. It happened right here.
Physical horizon shadow test under the globe model. Like you see here, the shadow of the pillar must rise higher up the wall than the pillar itself. Essentially, the globe will produce a measurable upward shadow on all objects in sunlight, and the shadows of all objects should always rise higher than the objects themselves. Now, I said earlier that I think it's theoretically possible for a shadow to appear upward in a flat Earth model, but the angle would probably be so minute that it wouldn't even be measurable, but I still agree with what Shadow Reveal is saying here. So, if you were looking at two buildings 50 stories high next to each other, and the first building was casting a shadow onto the second building, essentially the first building would never cast a measurable shadow higher than the building next to it. This is where many of you could contribute by either filming these shadows or sharing your mathematical or drafting expertise. There are many places in the world that these types of tests could be conducted. Anyways, watch this video and let me know what you think. Again,
Yet
head over to
nobody
his channel
seems
to
to have
subscribe,
done it.
and the link is in the description. A big thanks to Shadow Reveal for your participation.
Yeah, this is a good one.
And this is why I
They
love
can't model
Flat Earth.
the sun underneath the clouds either. The angle's too sharp. Wouldn't happen.
So I actually did a second shooting later on in the season that didn't quite turn out right because my camera just decided to turn off. But the difference, the improvement, is that I also marked on the wall with a magnet the height of the top of the opening of the doorway transferred straight across level.
Yeah.
Right?
Nice.
So you could see it approach that, but never exceed it. So I want to get that happening this summer. That'll be 6 months from now for me.
Nice. Ion in the YouTube chat says, can you please ask Stone if the opposite would occur in the morning, fade in, and then stay bright until it starts moving?
Yeah, the opposite, exactly. It would fade in where you're seeing it fade out, and then it would slowly accelerate downward.
Yes. Or the answer, Ion, is yes.
This is so serene and soothing, though. I'm just gonna let it play. I've never
That's
seen
actually
it.
something I could shoot in my bathroom. Now, thanks for mentioning it, Ion, because I have the same setup going on with a wall on the east side of my house.
Nice.
Its shadow would necessarily be caught on the west side of that room. It's a much tighter, it's a much shorter distance wall to wall than what you're seeing in the one I sent. Like about a third, quarter of the distance. But yes, it would still be quite noticeable as an angle. And yeah, I could just transfer the height of the window straight across. And yeah, that'd be neat.
Nice, dude. New Man of Stone video?
Yeah, what?
Awesome. Then maybe we could do like a premiere song about sticks and shadows or whatever. Like, you know, whatever you're feeling.
Are you gonna go ahead and crank that one out, Alan?
Yeah, I think I might do the vocals on it. If Stone does the
We're gonna create a new character over it. We're gonna call it Aether Cos my salad.
Well, you could always start with this basic, right, and then build from here.
We got Eratosthenes versus Eratosthenes my salad, and yeah, it's gonna be rough.
Eratosthenes my salad. I like pretending the Eratosthenes was like the retarded cousin of the actual dude who made the measurements called Cryptosthenes, who there's actual, you know, evidence of, who didn't just write a book one time.
Walking the 800 kilometers.
Yeah, he was like, you know what it was? He was in the canoe of magical longitude, because when they invented longitude at Parkes, he was there hanging out. No one using longitude until 1700. So he was able to use it to shoot all the way up to wherever the hell he needed to go. So being 800 kilometers away using longitude as like a shuttle, I bet. Yeah. A lot of the people were like, dude, they didn't have instantaneous communication. And I'm like, yeah. Don't overthink it, guys. I'm already like assuming that light is parallel and a whole bunch of other stuff. Like, it's fine. Fine. Just play pretend with me. We still win. Don't worry.
I took a look at the notes that I made when I produced my video, and towards the end, I actually replay it twice. Once at 4 times speed and once at 16 times.
I didn't think you could be jarred into like the absence of something that I should be seeing shouldn't be jarring to me. It's like, oh yeah, I've never seen that, and I should have every day. Okay, that's a solid point. It's like, ouch, globe.
Try switching back and forth if you can between this simulation number 2 here and my vid, because the similarity is striking.
I had it on standby. I was getting ready to do exactly that.
Yeah, cool, man. Just the last 20 seconds of the vid, you know, that's all you need.
Yep, this is it. I had it on repeat before when it goes to 16x right here. Boop, boop, boop,
Dude,
gone.
we're watching this shadow not move at all. Meanwhile, there's this dude in YouTube chat just freaking out. It's a globe. It's a globe. Like, bro, are you aware that this shadow would move up if it was a globe?
You can't deny the evidence.
Wait, what are we doing here, dog?
It's a globe. It's a globe. It's a globe. Well, that's a sound argument, buddy. Like, you keep at it.
Yeah,
this
dude.
is how we crush them.
But my globe.
And like, if I was like the world's most ruthless, most intelligent glober, I would misunderstand all of this, and I would just hammer that when you misunderstand azimuthal equidistant projection, and you try to draw a ruler to where you think the sun is in reality, it doesn't match up. But it does match up if I just move that angle to infinity, and that makes you wrong.
Ruicize it. Gotta ruicize.
You gotta look at it through a theodolite from 75 miles away. Is that what you said?
Yep, that 3-inch travel of optics, that does it every time.
Well, my sphere can have an infinite radius, so I also win.
Oh, infinite radii.
Dude, I'll invoke refraction, the radius of the celestial sphere. Come at me, bro.
Oh. I think the sky is an oblate spheroid, and we need to correct our devices on the ground in accordance to that.
So your equipotential, directional equipotential, geopotential, or whatever.
Yeah.
We need to plant really big sticks in the firmament and draw the same line.
I think this is, who's this? This flat Earth dude? Forget. Another nice optics perspective thing. I think it's the one I've been stealing from, actually.
Earlier, the sun does not go over the horizon, it goes into the horizon, moving beyond the limit of our vision with our
Hey,
normal
it says the
eyes.
same thing.
But if you take a telescope or a good camera and zoom in on the sun as
And that
you
was
think
from
it's setting
P-Bane,
over the
right?
horizon,
Though
you can
the
see
animation.
I don't. Yeah, see, everyone steals from everyone. So this is like flat out Truth Brothers video that somebody else is commenting on, but it's a visual from P-Brain. So I don't know, man.
right here. It'll
Thank
pop
you, Flat
right
Earth
back
community.
up into the sky because your eyes can't see that far away. It looks like it's setting over the horizon.
He's actually saying the
going
same thing
over the
that we always
horizon,
say,
but
though,
it's not.
so.
It's just going so far away you can't see it anymore with the naked eye. But as you see right here, with a telescope or a good zoom lens camera, it pops right back up into the sky, proving that it doesn't go over a curved ball. And that is the law of perspective. Everyone, thanks for watching. Have a good night.
That guy just loves his voice.
Right? Like, I got the same thing. All right. Crap. Where am I playing?
Did you say he kissed himself at the end of that? Gave himself a little peck on the cheek.
That can't be. All right. Where am I playing this from? Is everything okay? You guys can see this again. All right, cool. Oh yeah, no, there it is. Right. This is a nice little. Does this not perfectly answer all the stupid questions? This little
It's the
gift.
solar yo-yo.
It's like this is what happens. It's like, no, that can't possibly happen. It's because of those sphericity. It's like, nope. Again, this is what happens. Because based on all the evidence, you know, the converging corpuscular and anti-corpuscular rays, we have a front convergence, a rear convergence, right? So your vision is doing this. And in that vision, you see this object, which is approaching you, and then, you know, approaching and receding, rising and setting. That's it. And then, of course, this is supposed to represent spherical limit of review, and this is also going to represent how on the western bank of Australia, you know, the sun can be seen to rise slightly south of east, or whatever, south of east, and then set south of west, right, to form a little frowny face like this a little bit because of the curved nature of your vision, as everybody knows. Dude, I remember when like Globers presented this one as if it was an insult. And they were like, "Look how stupid you are," and I was like, "Yeah, yoink."
Sabine Hassan used that one.
Oh, you're talking about Savine Hoffenstoffer?
Sabine Slassenblacken.
Oh.
Hassan.
I mean, I grabbed it. It was like, yoink, this is a great visualization. Thank you. I'm going to use it to display. And now it's like this war where they'll use it against us, but we'll use the same thing, and it's like a standoff.
Sabine Lederhosen.
I heard she's been hitting up Toby in the DMs.
Is she showing you her curves?
Who?
Sabine Hoffenfelder Stutterson.
Oh yeah, all the time.
She was like, "Oh, flat Earth dangerous, Toby," or whatever.
You don't know what science is.
lines.
You don't know what science is.
Come back to globe, Toby.
Yep, dangerous. She just cares about us.
Hence, trigger Toby.
She doesn't want to. Really. She doesn't want to see you go down the wrong road. She knows you have a lot of potential, and you just need to apply yourself to globular theory.
Interesting. Oh, very dangerous to go down that road.
You know what your problem is, Toby? You just don't.
Oh no, I need him
believe in
triggered.
hard
I need
enough.
triggered Toby.
That guy's growing on me. I like him.
No triggering here. Not tonight. At least, I'm sure it's possible somehow.
Stone, what do you think Sabine would say about all this sun stuff Shane's talking about?
Well, the angle is so hard to calculate.
Let's hold on.
I just don't think he knows what science is.
Let's finish up on our toroidal sun. What do you guys
I'm
think?
not qualified to talk about this sun.
Does anybody know what this is right here?
Pinhole camera image.
Is that the fake
Napalm's
Analemma?
Too smart. Too smart.
An atmospheric occlusion.
There's definitely a pinhole camera, right? It's the sun's path in motion, and it's like, oh, that looks like weirder than anything that they'd ever show us about it. And it's like, it does, but you know what? It does resemble almost exactly is the 3D model of the model that put together by Flat Earth, those magnetic Flat Earth people, right? Which we should watch probably a section of to finish off the night. Let's see here, right? What are you thinking?
It's the Analemma.
We're gonna go round in circles.
Do I have it?
And put it in the middle of all those sun rays, because that's what the Analemma is the sun's path.
I don't know if you've ever seen this one, Kat, but you should watch this one if you've never seen it. You probably have, though. I inflict this upon as many people as I can every time, and if I've inflicted it upon you once, I'm gonna inflict it upon you again with no regret. So, you guys ready? It's like 10 minutes of this one, I think.
Yeah, before we begin, though, I just got word that Sabine is now issuing a meme coin and an MTF on something called XRP Ripple. Like, I don't know what that means.
Wow. Yep.
But
if you guys want to get really, really rich, then go hop on to the new Ripple Web3 coin. And I'm sure they've got some very, very trackable technologies that you can tokenize yourself for. And so go ahead and go tokenize yourself. And if you haven't tokenized yourself yet, well, we already all did. So that's on you. And then go tokenize yourself, join Web3, and then go buy Hassan coin and just hodl your Hassan coin and hang on there until when's Hassan coin gonna skyrocket? Alan?
well, they say it's going to go to the moon, so that's probably true.
Ah, well, I like that analogy.
And I quote John Oliver, and I quote, "Hodl gang, hodl gang, hodl gang, hodl gang, hodl gang, hodl gang, hodl gang."
That and we're particularly that was him talking about Hassan coin. So
yes,
yeah.
Nice.
So there you go. Pick up your Hassan coin. Don't worry about the fact that me and Sabine have split the 95% or the 94% pre-mine. We've split that 47% each. So don't mind the fact that I will own 47%-ish of the liquidity of whatever you buy into. And Sabine will also own 47%.
No problemo.
Anyways.
Angles on any given day of the year.
Oh, did I miss this spot?
The hyperbolic
There we go.
paraboloid shape of the sun Analemma is not just a path over a year time span.
That is a Pringle.
That is a Pringle.
That is a contour.
Hyperbolic expression call. What do we have?
But that same motion is found in the sun's 24-hour cycle.
Super loud. Turn it down a little bit.
This drift pattern becomes obvious when you track the sun with high-end trackers
Boom, this is like the best part ever.
like Los Mondi trackers and just track the azimuth of the sun and do not use the correction adjustments of the tracker so that it runs on its nominal speed of 15 degrees an hour. The drift pattern is also equal and opposite on both sides of the equator, which means that this small 30...
Oh my god, dude, he said this so long ago and I just been glazing right past it like it was
Equal and
nothing.
opposite, dude.
God damn it, you heard it too. Dude, I was like,
Yeah.
I've seen this so many times and I've been like, nah, it's hold on.
Right, back 10 seconds. I was totally distracted.
Yeah.
the tracker so that it runs on its nominal speed of 15 degrees an hour. The drift pattern is also equal and opposite on both sides of the equator, which means that this small 39.8 mile diameter sun is moving across the sky at various observed speeds north and south of the equator. After 2 years of research and modeling, we were stuck.
Right, equidistant from the equator was the point. That means the Analemma isn't bigger and fatter on one side. It's an equidistant perspective, latitude dependent in the infinity.
Right.
So,
The important takeaway there,
yeah.
which will also come into play when we get into the next part or the next video.
Hell yeah.
Stuck and couldn't make it work to model the sun or any object accurately. We started from scratch. We came to a revelation many, if not all, flatheads have overlooked.
The one ray to your foot example, one of my favorites, dude.
When you look at crepuscular rays piercing through clouds over a lake or plain, for example, the angles of the rays end up at the actual light source, which is just above the clouds in most cases. But we know the sun is not right above the clouds. We started wondering what someone would see looking back from the other side and if he or she would see the same thing. Imagine a scenario where you see these rays over a lake. Those rays are lighting up a spot on the water. Now put another observer right across the lake looking back at you. Can he see those rays in that lit up spot on the water like in this animation? Let's take that one step further and give the primary observer seeing the rays a long pole with a mirror attached at the end. If he were to reflect that ray hitting the water to the observer on the other side, would he then see a reflection of the sun in that mirror? Keep in mind the distance apart here is only 40 kilometers, and where the sun should be for the observer on the other side.
It's okay, Jesse. You'll figure it out pretty soon.
To make these light angles in 3D software, you will need, like we used here, a local light source. But in reality, when you move to the other side of the lake and turn around to look back, you will have the sun at your back. Therefore making it impossible to see the rays in the first scenario or the reflection of the sun in the mirror. We have therefore come to the logical conclusion that those rays are personal for any observer, as someone looking back cannot see the same thing because of his position towards the sun.
Crazy, right?
Now, if those rays are personal and cannot be seen by anyone else but the observer himself, that indicates that the sun is a personal or local objective projection.
Like a source projection.
This
like
can
a
be
rainbow.
verified by anyone by doing the opposite side crepuscular rays experiment, like in this animation, and see that someone looking back at someone seeing those rays cannot and will not see the same thing. A rainbow acts the same way as the sun, being that you can only see it at a specific angle, and you cannot walk around a rainbow as it will always move away from you. And you cannot see the opposite side of a rainbow. A rainbow is a source projection, and its source is...
Does anyone know the full shape of a rainbow?
The sun.
Circle.
Therefore, if the
Isn't it a
sun is
circle?
also a
Circle.
source projection of an unknown
It's
source,
something you-
we can start modeling the path of...
Hey, watch
It's
some
something
stuff.
you can do on your front lawn with a hose in the summertime. When the sun's hanging right behind you, up over your shoulder, do the misty thing on the shadow side of yourself and look at the entire circle. Average.
Dude, what is this, guys? What do you see here, Alan?
Big old rainbow?
No, it's a fucking graph of an equidistant sun plot. Again, from the equator, should have been longitude dependent. Like, this is the
sundial
Analemma.
plot.
Yeah. So, like I have this now in my proof of how I know why it's equidistant and not perspective. And this guy, not only did he say it verbatim, but he had this same proof in it too. And I didn't even notice it, guys. I'm retarded. They got for Stone, man, pointing that stuff out. They say, hey, look. And I was like, oh.
the sun for each observer on Earth. We did this by taking just one longitude, that being the 0 UTC meridian on Earth. And inputted the data from observations for azimuth and declination of the sun and traced the sun object for that location for a year for each 10th latitude north and south of the equator, and just let the data run its course for a year.
Dude, this is the craziest thing that I've ever seen.
But the model became so heavy with data and tiny hair-thin tracer lines that even with a super machine, we couldn't render the result. After some trial and error, we finally managed to get a clear view on the end result. And even with our sun being an equal distance to the observer, the shape and layout ended up in a torus field around the Earth.
More like a sombrero.
Oh yeah, a giant fractal torus field.
It's like, darn it, it keeps coming up.
We still have to figure out how to do proper 3D vectoring to get all the observed speeds and changes in the motion of the sun, creating a more true shape. But it became very clear to us that based on Ken Wheeler's research into magnetic holography, that the sun we see is projected into the electromagnetic field in the sky. The objective sun follows the magnetic field lines that are unique for each location on Earth.
I think every couple of months we should just
So the real
rewatch this
sun is
video.
a source coming from outside
Right?
of the so-called firmament, which probably
this is
uses
good.
light polarization that is projected into the magnetic field and rendered through
Like I
the
said,
atlas
he's like,
plane.
"Do you have it?" I'm like, "Yeah, it's in my wallet."
It is no
Hold on, let
coincidence
me go
that
get
all
it.
sun arcs combined create this torus-like field, and this is version 1.0.
Like, I don't leave home without it, man.
As soon as we find out how to use equal distance 3D vectoring and a formula on the angles in the data sheets from observations, we can then get a true shape in second-by-second motion in the field lines. This torus field is by no means a stationary field, as the sun moves north and south during the year. We animated this in what we call the cosmic breath of flat Earth, and this shows that by simply increasing the current in the field from the North Pole, you then push the field south, and by lowering the current, it flows back north again. It can also be pushed back and forth by an outside magnetic field from beyond the Antarctic, 90 degrees south latitude. The southern magnetic anomaly is also a moving anomaly, and who knows what more lies beyond the southern latitudes, all of which have influence on the field. From a creation standpoint, it must have a function as well. If we animate all sun positions over a year, the animation gives the impression of a wave going around the field like an outside source pushing and pulling
look
on the
at
field
that.
and
Not a bunch of
projecting its
points, you
image,
say?
that being the sun or moon in it.
Always a wave, you say. That's weird.
Always has been.
We should assume it's multi-discrete informational packets and points or whatever. I think that.
We do not know yet what our aims of physics are for.
I think it's pretty much it. I think it's just cool visualizations from here on out. But
Sombrero of Doom.
let's I want to take a couple like seconds. This little like the thing about the sun. The sun is one of the engines of our world, really. The sun and the moon are dynamic forces that like cause everything, that cause seasons, the interplay, the difference in the speeds between them cause what ends up being the eclipse cycle, which is the only chronometer, which is end up affecting the tides way more than they say with mass attracting mass. That's not through it. It's like, through its dielectric and magnetic nature, through telluric currents and perpendicular things that it actually can interact with, right? We see that through infodromic points, but like the sun and the moon are the dynamic cause of everything. That wave that this is illustrating is like the engine of creation. I think the flat earth philosophy calls it toroidal tropics of creation, specifically for that reason. And I think Alan's going to show us how that this thing has been measured repeatedly. And even though they're using it as the barometer, it's the barometer of everything. This little illustration is why the speed changes and slows up depending on how high you go. And I think Dayton Miller and a bunch of everyone who's ever used an interferometer will corroborate those measurements over and over and over and over again. I love that last one. It's so mad. It's so like epic with the music. This thing.
Yeah, whenever you're ready, just switch to Stone's video, and we'll watch that first.
Which one? The one we already played?
No, the video on his BitChute channel, a couple thoughts about the sun, I think it is.
Oh, you got it ready to go?
No, I'm saying for you to go do it, but I'll do it for you.
Yeah, you can.
I was trying to have you do it because for some reason.
Do I hear RuneScape clicking? I feel like you can have an extra screen going. I think.
What's happening?
He's like, all right, cop.
Busted. Man of Stone. But you do have to play the video, though.
All right.
For Linux reasons. Linux-related reasons.
Yeah, I know. Windows sniffing your packets is superior to not being able to play audio. I heard you the first time.
It hurts.
I can't believe I'm defending Bill Gates, guys. This is an awkward position you both have put me in, okay?
Bill needs a sniff.
Just give me a...
Dude, I never put anyone in... I hate this conversation.
I'm just kidding, dude. So that was the best, sun video ever created by any flat earther, period, I think. So whatever. Is that... Even though, like,
Yeah, I was freaking out. That came out in 2017, and I was freaking out. I'm like, why isn't everybody like freaking out about this? Why is this not like everywhere being like totally viral? It's weird.
Because people were too busy swiping.
Getting swiped up.
I guess so, or just focused on long distance observations and keeping the flat Earth discussion going.
yeah, they were like, hold on, but is it water? Can I talk about water, or like how it's not on the horizon? Otherwise, we don't really have. I don't understand. Like, we're not allowed to.
Yeah,
we're not allowed to talk about them.
It almost seemed like it.
Well, I remember specifically being gaslit out of ever considering the sun being like, 30 miles and then 39.59 away or whatever, because that's kind of what it works out to be, right? Where it's 62.10, and then the actual, size in miles doesn't really matter, right? It's just based off angular, but that's what it would scale out to be. But
on sphere, yep.
But it's like, if it's a physical object, then like, yeah, you can't have that. But like, having the incomplete understanding that it's an apparent object that's relative to you specifically, that, that completely changes the nature of it, right? Because now we're dealing with something that's not in the sky, that it's like, oh, well, that's a physical thing, right? Because when they get into the measurements real quick of spectroscopy, solar spectroscopy, they see a continuous spectrum emission, and nothing in the lab ever has emitted a continuous spectrum. Like, they don't even know what what could possibly do that. So the idea that it's like made up of a thing of like material mass, and and it's X distance away, is just like, they really got everyone with that, dude. Because that's like one of the biggest, like you're saying, the sun is like the backbone of heliocentrism and globularity, for the reasons of how they try to triangulate it and apply it. And you can't. But they know, the people that tried to do that obviously knew that back in the day. And then this is like the workaround hotfix version that we're dealing with, where it's like, yeah, you can do it. Just assume it's super far and that the Earth bend.
just assume that it's forever away. How long? Forever. How long? I gotta put something on the form, Bob. All right. 93,676,973. All right. Forever. I got it.
Yeah, it's awesome. So let's play Stone's video out, unless anyone has anything else to add.
This is an awesome 4 minutes packed awesomeness.
All right.
I've got a song, I ain't got no melody. I'm gonna sing it to my friends. I've got a song, I ain't got no melody. I'm gonna sing it to my friends. When I go round in circles, when they fly high like a bird up in the sky. When they go round in circles, when they fly high like a bird up in the sky. I've got a story, ain't got no moral. Let the bad guy win every once in a while. I've got a story, ain't got no moral. Let the bad guy win every once in a while. When they go round in circles, when they fly high like a bird up in the sky. When they go round in circles, when they fly high like a bird up in the sky. I gotta dance, ain't got no steps, no. I'm gonna let the music move me around. I've got to dance, I ain't got no steps. I'm gonna let the music move me around. When I go round in circles, when I fly high like a bird up in the sky. When I go round in circles, when I fly high like a bird up in the sky. to my friends. I've got a song, I ain't got no melody. I'm gonna sing it to my friend. When I go round and circle, when it fly high like a bird up in the sky. When it go round in circle, when it fly high like a bird up in the sky.
What an awesome video.
Dude, great video. Let's talk a little bit about what we just watched. So the geometry of Earth's orbit, they say, is, you know, an ellipse, right? It's on an elliptical orbit around the sun. So that would dictate that it speeds up and slows down 4 times a year. And when you realize that none of that takes place, and it just happens twice, corresponding with the equinoxes, that it's, you know, symmetrical in both hemis, and that it's all derived, or, you know, that the geometry of the Earth is derived from what's going on in the sky. So, you know, the tilt of the Earth is just the sun's ecliptic. And then when you realize that, or not realize, but when they took measurements of radiation in the sky, they found that there was a preferred orientation for that radiation, and there was an intersection with the sun's ecliptic, where essentially you could say that the universe rotates around, you know, with the sun's ecliptic. And that's what Dayton Miller measured, right? So for heliocentrism to be true, they would have needed a measurement of 30 kilometers a second. And in addition to that, there would have been minimum and maximum peaks for the measurements that would correspond, you know, to slowing down and speeding up 4 times, you know, twice a year, right? But 4 times a year, but it only happens twice, right, on the equinoxes. So when they talk about the motion of the sky and all of that with Kepler, and, you know, it's this ellipse is 3% off a deviation from a perfect circle and all that. Well, what it could be equally said is that everything is happening in a circle that's oscillating above us. And, you know, that's further substantiated by the measurements of ether wind that reach minimum and maximum dimensions twice a year. So, and the fact that the sun's ecliptic is intersected by the background radiation in the sky, it's just, you know. Do you have that visual that Patricia made, Shane? Of the sun doing its analemma over a flat Earth? As if not, it's cool. But yeah, I just wanted to kind of end on that, right? Because their model makes very specific claims about the motion of what's going on in the sky and our motion, right? And as Stone just eloquently laid out, none of that is what is applicable to how they actually derive everything. It's based off of the equation of time, and that shows this symmetrical slowing up and speeding down twice a year. So, did I miss anything?
No. Yeah. Well said.
You've really tacked it up.
Nice.
Anyone have anything else to add, or any of the topics on this impromptu sun presentation that I think ended up being pretty badass?
Yeah, I got something to say. Earlier in the presentation, when you were talking, I was kind of losing energy. So I went downstairs and made some coffee that I ordered from brushtail.coffee.
Oh yeah, is that so? How was it?
Yeah, I tried some of this Ethiopian blend. It was really good. It tasted kind of nutty, kind of fruity, but it tasted like not some DS store coffee that you get off of a shelf with an expiration date. Imagine buying coffee that expires. That's so sad. What do you like? That's some peasantry type
When your
stuff.
coffee has an expiration date instead of a roasted date, you're in a
Different
dark
world,
place.
different world, bro. You know.
Yep.
Now,
if you want coffee that's roasted by one person on a grill with a special setup and it's fresh, like literally I'm gonna roast as soon as we're done here. I have to drop off here to go roast, and I'm gonna be shipping coffee to people, including the mayor and maybe definitely another special customer, Mr. Austin Whitsitt. So, if you wanna sound like Whitsitt when you talk, then you wanna talk about the centripetal divergence of the centripetal convergence, the centrifugal divergence.
You gotta get
Then you
roasted tail
need
coffee. Yeah,
you need some
100%.
brush tail coffee. Yep, exactly. So there you go.
You should make a word salad blend. That'd be great.
Yeah, I drink a pot a day, and I'm trying hard, but you can too, guys. So,
So yeah, there you go. Head on over to brushtail.coffee. And also, yeah, so we'll just go ahead and wrap it up here. Thanks everyone for tuning in. Unfortunately, we did not have Cassandra's presentation on Hildegard tonight, which is a bummer because I think we're all really looking forward to number 2. But maybe we could all go rewatch number 1 to really tie ourselves over until number 2. So maybe we can put that on our agenda. In any case, thanks for being here with us. Thanks for listening. Thanks to everyone that was here and chatted. Thanks, Shane, for sharing all your slides. That was cool to be able to do something impromptu like this. So yeah, thanks everyone for being here, and check us out on Thursday night for a live X Twitter Space conversation. Join us on X Twitter Spaces for that. And then check us out next Monday night. So on Thursday night, we do it at 9 p.m. Eastern. And then next Monday night, we'll be doing reading at 9 p.m. Eastern here on the Discord server. And then next Tuesday night for another presentation for another Aether Roundtable at 8 p.m. Eastern. So check us out for all of that. And everybody take care.